A mixture containing 0.2 moles of hydrogen and 0.3 moles of nitrogen has a total pressure of 720 torr. What is the partial pressure of H2 in the mixture? Partial pressure is defined as the pressure that a component of a gas mixture would exert if it were alone in the container. Assuming ideal behavior, we can calculate the pressure of a gas by rearranging the ideal gas equation. We get P equals nRT over V, which is shown here as equation 1. To calculate the pressure, we need the number of moles of gas, N, the ideal gas constant, R, the temperature of the gas, T, and the volume of the gas, V. We can use the same formula for partial pressure. For example, the partial pressure of hydrogen is equal to the moles of hydrogen times RT over V, as shown here in equation 2. Unfortunately, the problem does not give us the temperature or volume of hydrogen. So what do? We can get rid of the need for temperature and volume information as well as R by taking equation 2 and dividing it by equation 1. If we do, we find that the ratio of the pressure of hydrogen to the total pressure is just equal to the ratio of the number of moles of hydrogen to the total number of moles. The ratio of the number of moles of a component of a mixture to the total number of moles is called its mole fraction. Mole fraction is generally represented by the letter X, with the name or formula of the component indicated as a subscript, as shown here. So, to calculate the partial pressure of hydrogen, we simply multiply the mole fraction of hydrogen and the total pressure. 0.4 times 720 equals 288. The correct answer is 288 torr. Choice C. If you're wondering how we figured out 0.4 as the mole fraction of hydrogen, it's simply equal to the moles of hydrogen, which is given in the problem as 0.2, divided by the total moles of gas, which is just the sum of the moles of hydrogen and nitrogen. The amount of nitrogen is given as 0.3 moles in the problem. In general, the partial pressure of any component of a mixture is equal to its mole fraction times the total pressure. In the equation shown here, P sub A is the partial pressure of component A. X sub A is the mole fraction of component A. And P is the total pressure. If we were interested in the partial pressure of nitrogen, we would multiply the mole fraction of nitrogen, which we can calculate as 0.6, and the total pressure, 720 torr. 0.6 times 720 equals 432. The partial pressure of nitrogen is 432 torr. Note that because mole fractions add up to 1, partial pressures of components of a mixture add up to the total pressure. In the case we have here, the partial pressure of hydrogen is 288 torr. The the partial pressure of nitrogen is 432 torr. The partial pressure of nitrogen is 288 torr. The partial pressure of hydrogen is 288 torr. The partial pressure of nitrogen is 432 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 torr. The partial press 288 plus 432 equals 720. The total pressure is 720 torr. This concept is known as Dalton's law of partial pressure.